Hey, what is going on, guys, and welcome back. This is going to be part two, continuing from the previous video where we were learning about loops in Python. In this video, we're going to be getting a little bit of practice with loops uh, in Python. So I prepared a list of exercises for us, about 9 exercises. They go from pretty easy to, they're not difficult by any means. And I chose to keep them pretty straightforward because I believe that we can still build a pretty good foundation about working with loops moving forward in the course. And whenever we're going through the course material, um, we use loops all the time, so you can get even more examples through there. But I just wanted to create some practice exercises for us, and we will do them in using while loops, using for loops, and just to get some extra practice. So the first exercise here, we're just told it's pretty simple. Print the string hello world 5 times, and this is the expected output. So I'm just going to go ahead and copy this. And I have the Python playground opened up over here, so just to keep things pretty straightforward. Um, so we need to print the string hello world 5 times. So we're going to first do it using a while loop, and then we're going to do it with a for loop. So we're going to say I is equal to 1 while I is less than or equal to 5, print hello world, and then I plus equals 1. And there we go, we get hello world printed 5 times. Now, if you wanted to do this with a for loop, you would do for I in range 5, print hello world. I'm going to put a space here. So same thing, same output. This is a little bit shorter. Again, one of those things we talked about when deciding if you're going to use while loops versus for loops. For loops are a little bit more easier to set or faster to set up. Right? You don't need any helper variables to set up the loop, right? But again, this solution to this exercise is pretty easy. You can do it with a for loop and with a while loop. So that's that first exercise complete. Now, this second exercise, we're told to print the integers 1 to 5 inclusive. So the expected output is to print the numbers 1, 2, 3, 4, 5 in ascending order like this, and make sure that we have 5 included. So we're going to do it with a while loop and then with a for loop as well. So here it's pretty simple. We're just going to print I. There we go. We get 1, 2, 3, 4, 5. Same thing here. I'm going to uncomment this out, and we're just going to print I. Now, we just need to update this and give it our starting number. And if you remember, when you're using the range function, the first argument that you pass will be where you want to start your count from, and the second argument will be where you want your count to stop, but it's not going to include this stopping number. So this is going to count from 1 to 6, not including 6. And there we go. We get 1, 2, 3, 4, 5. Here we get 1, 2, 3, 4, 5 as well using a while loop, and this is with using a for loop. So again, pretty easy stuff. Here we're going to print the integers 5 to 1 inclusively, but now we're doing something very similar, but we're counting down. So we're going to start from 5 and go down to 1, including 1. So again, we're going to say I is equal to 5 here. And so, well, I is greater than or equal to 1, print I, and then we're going to say I is minus equals 1. So this is how you do compound subtraction, right? When you compound the arithmetic operation you want to do with the assignment operator, the equal sign, this is how you decrement. So when we run this, we're going to get 5, 4, 3, 2, 1. And now if we were to do this with a for loop, we're going to say for I in range, our starting number is going to be 5, our ending number is going to be 0, and we're going to pass negative 1 here. So if you remember again, with the range function, you can pass up to 3 arguments. The first argument is always where you want to start, the second argument is where you want to end, and the final argument will be how many steps you want to take. So when you pass negative 1, we're telling Python, hey, count down. instead of up. And then if we were to pass a positive number, it would be counting up, which is going to be impossible to reach 0. But you can, do -1, you can do -2, -3 to, change how many steps you want to take. And again, here we're just going to say print I, and that's just going to be it. Now, we also get 5, 4, 3, 2, 1. So that was also pretty simple. Here we're told to calculate the sum from adding the following integers. We have the integers 1, 2, 3, 4, 5, and then we're told to print out the final answer. The expected output is sum is equal to 15. So I'm going to create a variable here called sum, set that equal to 0. And down here I'm going to say print sum is equal to sum like that. So that's going to be our final output. Then we're going to say I is equal to 1, while I is less than or equal to 5, sum plus equals I, and then I plus equals 1. Now when we run this, we get 15. And then how do we do this with a for loop? I'm going to comment this out. I'm going to say for I in range 1 to 6, sum plus equals I. And then when we run this, we also get sum is equal to 15. Okay, pretty simple stuff. And we come across these exercises in the Python course so far, so it's nothing new. This is just taking some of those exercises and doing them in a vacuum, basically. Exercise 5, we're told to print out the even numbers from 0 to 20 inclusive. So inclusive meaning include the 20. And the expected output will be 0, 2, 4, 6, 8, 10, all the way down to 20. So we're printing all the even numbers from 0 to 20. So we're going to say I is equal to 0, while I is less than or equal to 20, print. Then we're going to say if I, so remember the modulo operator, this is division with, and it's going to return the remainder. So we're saying if the division of our current integer by 2 is equal to 0, then print that integer. Right? So, right, if the remainder is 0, that means we're looking at an even number. That way we can print that even number. And then we're still going to increment I by 1 to make sure that we get to our terminating condition. So when we run this, we get 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that's how you do that with a while loop. Now we're going to say for I in range 0 to 21, print, then we're going to say the same thing. If I %2 is equal to 0, print I. But the beauty here is that we don't have to increment anything outside of this. Right? Python's going to take care of the incrementation from our starting number to our ending number. There we go. We get 0, 2, 4, 6, 8, 10. And another neat thing that we can do here is we can pass our third argument, if you remember, which tells Python to go up 2 steps. So we don't even have to do this if we do a for loop. In fact, actually, I'll keep this solution, and I'll print out another one. And in here, we're going to pass 2, and that's going to tell Python, hey, go up 2 steps each time. And there we go, 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So these are 3 different ways to do the exact same thing. And this might even be, even more simpler than this by doing this conditional to check if the current number that we're looking at is divisible by 2 and returns no remainders. Right here, we can just tell Python, hey, start from 0, go up to 21, not including 21, because again, that's how the range function works, and go up by 2 each time you increment. So start from 0, go up 2 integers, so that's going to be 2, then 4, then 6, then 8, and then so on and so forth. So that's the solution for this exercise. Here we're told to count and print out the total number of vowels in the given string. This is our given string. The expected output is total vowels in the string. This is an example, is 6. So we're going to set a variable here called vowels, set that equal to 0. Then we're going to print total vowels in the string. This is an example, is vowels, like that. Now, what you can also do is set the string as a variable, like that. And then that way here, we can pass my string just to make this a little bit dynamic. Then we're going to say I is equal to 0 while I is less than or equal to the length of my string if a, e, o, u in my string vowels plus equals 1, and then I plus equals 1. So first of all, we need to fix this. And there we go, total vowels in the string. This is an example, is 6. So what's going on here? We're basically saying, pardon me, first of all, this is what we were. Right, now we got this error. First, we need to get rid of this. It's still going to give us an error, right, because we're comparing an integer to a string. We need to grab my string at that index, right? So whatever letter we're currently looking at is in this string of vowels. And if you remember, a vowel is the letters A, E, O, U, pronounced in that nature. So we're just going to check, hey, if the letter that we're currently looking at is in this string, then increment our vowels counter by 1, and then increment our index tracker by 1 as well. So now when we run this, we get the total vowels in the string. This is an example, is 6. So that's one way of solving this exercise. Again, it's pretty straightforward. So how would you do this with a for loop? We're going to say for character in length of my string, if character in a, e, o, u, vowels plus equals 1. So we're going to hide this and run. Oh, I'm sorry, this needs to be range. What am I doing wrong? I'm sorry, I'm overcomplicating this. Right, we can, remember, I have to remind myself this. Strings are, again, sequences, right? We can iterate through a string. So we can just do this. So for character in my string, check if the character is in this string of vowels. If it is, increment vowels by 1. And there we go. The total vowels in the string, this is an example, is 6. I was completely thinking of this a little bit backwards. This was going to be very verbose the way I had it in my brain. And I just had to remind myself, like, hey, strings are also sequences because we can do this. My string at I or at 0, right? This is going to return the first letter T here. If we wanted to get this S, this would be 0, 1, 2, 3. So we're going to pass a 3 here, etc., etc. So because we can do that, we can do this with for loops. So we're going to say for character in my string, if our character is in this string of vowels, then increment our vowels counter by 1. And that's the solution to this. So you can do this way, or you can do it this way. Again, as you can see, right, with while loops, it's a little bit more verbose. You have to keep track of this counter here. You have to make sure that you increment it so we can reach the terminating condition and things like that. But in here, you know, it's a little bit more succinct, right? We don't have to have any helper variables. We can loop directly through the string, grab each character, and then check if that character exists in our string of vowels. And if it is, increment vowels by 1. Very, very simple stuff. Okay, here we have another exercise called print a multiplication table. And the expected output is this. So you can do 1 times 1 is equal to 1. 1 times 2 is equal to 2. 1 times 3. So we basically have to do all the 1s times all the other digits, then all the 2s times all the other digits, and the 3s and the 4s, and et cetera, et cetera. So here we're going to say, so again, I is equal to 1. We're going to say while I is less than or equal to 12, print, not print, we're going to say j is equal to 1 as well. While j is less than or equal to 12, then print, we're going to use f strings, I times j is equal to I times j. And then what we're going to do here is j plus equals 1. And out here, we're going to do I plus equals 1. I'm just going to put a space here. So Now when we run this, we get 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4, and so on for all the numbers up to 12. And on this side, we're going to go each 12 number each time. I mean, each 12 iterations of each number. So we're going to do 1 times all the way down to 12, 12 times, and then 2 times 12 digits, and then 3 times 12 digits, all the way down to 12 times 12, which is 144. How would you do this with a for loop? Pretty simple. For I in range 13, we need to start at 1, and then for j in range 1 through 13, print, and I'm just going to copy this like that. When we run this, we get the same thing. So down here we get 1 times 1, 1 times 2, 1 times 3, all the way down to 1 times 12, and then 2 times 1, 2 times 2, 2 times 3, all the way down to 2 times 12, and then for every number, all the way down to 12 times 12. So that's how you do this with a while loop and with a for loop. In fact, it's pretty similar outside if we didn't have to manually increment by 1 for each variable that we're using here for I and j. This will look pretty much identical, but that's just the trade-off that you have when you're using while loops is setting these helper variables for tracking where you currently are and then making sure that you increment. Otherwise, you're going to trigger an infinite loop. Okay, this exercise, we're told to draw the following square of asterisks. So to do this with a while loop, we're just going to say I is equal to 1 while I is less than 5, j is equal to 1 while j is less than 5, print this, and then j plus equals 1, and then I plus equals 1. And there we go. But, sorry, this needs to be less than or equal to. There we go, 1, 2, 3, 4, we're missing 1 row. And there we go, 1, 2, 3, 4, 5. Each row has 1, 2, 3, 4, 5 columns, just like this. So to make this even a little bit better for us, we can say, hey, row is equal to 1, and then j is going to be turned into column, or col for short, just for semantics. So now, our row count starts at 1, our column count starts at 1, and then for each column, print an asterisk. This, and when you pass it to this print function, is basically telling Python, hey, print everything on the same line. So everything we're going to print in this iteration, print it all on the same line, but we still have to, once we finish looping through for each column, print an empty line. Send us to the next line so we can do this. So basically print 5 asterisks and then start the next line. Then do it again, start the next line, do it again, over and over and over. Okay, now with a for loop, we're going to say we're going to set size equal to 5 for I in range size, for j in range size, print same thing, and then print an empty line. And there we go. Very, very, very simple. And these are the 2 solutions for that. Very similar, just the setup is a little bit shorter here. We only have to have 1 helper variable. Now you don't even need this size. You can just go and pass 5 here, like this, to even make it even shorter for ourselves. And when you run it, it does the same thing. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 rows, 5 columns. And again, if you want to be, have a little bit of semantics, you can call it rows and columns, and again, does the same thing. So that's that. And the final exercise is printing this half triangle that has 1, 2, 3, 4, 5 rows, and at its widest, which is the bottom row, it is 5 columns wide. So let's go ahead and do that. Well, I is equal to 1, I is equal to 1, no, I is equal to 1, while I is less than or equal to 5, j is equal to 1, while j is less than or equal to I, print that asterisk, and is equal to this empty space. This needs to be a string. J plus equals 1. Print a new line, I plus equals 1. And there we go. We have this half pyramid. It's 1, 2, 3, it's 5 rows tall, and on its widest point at the bottom, it is 5 rows tall and 5 columns wide at its widest point. And that's how you do it. Pretty similar to what the last solution. And then for using for loops, we just say for I in range 5, for j in range I, print this asterisk, same way, and run it. Oop, and print. This needs to go up to 6. There we go. So same outputs, 2 different solutions. So that's the versatility of while and for loops. You can do, again, so this is one of the things that I wanted to emphasize in the previous video, that you can do pretty much the same things with while loops and for loops, but when you choose to use them is entirely up to you. For loops are a little bit faster to set up, they're a little bit shorter to set up. You can get the same amount of work done with a for loop with shorter amount of lines than you would with a while loop. But it doesn't necessarily mean that for loops are all the way better. Again, they are better, don't get me wrong, but they're not like while loops still have their use cases in which they could be very, very useful. And one of those use cases is, as we talked about in the previous video, was if you wanted to create a program that runs for an unknown amount of times. So that's when you would use a while loop. So we'll say while true, then we can prompt the user for a name, right, like this. And then we're going to print the name. I'm sorry, I didn't mean to do that. Let's say if name is equal to exit, then we want to break, otherwise print the name. So this will run forever. Give me a name, Steve. Give me a name, Mary, right? So you can even make this a little bit more fun. You can say hello name, like that. So if I type in Steve here, hello Steve. If I type in Mary, hello Mary. If I type in James, hello James. And if I type quit, I meant exit. I typed in quit. If I type in exit, the program ends. So this is where a while loop is useful, right? I could keep this loop running forever and do as many things that I need to, right? In an example, we could have here a list of names. And then we could say, instead of printing hello name, we could just say names that append name. And then at the end, for name in names, print name. Right? So here, if I type in Mary, if I type in Steve, if I type in James, if I type in Alexander, right? And when I type in exit, I get all my names printed back. So this could be useful, right? If I have a list of students and I don't know how many students I have in this list and I want to add them to my program by manually typing this stuff in, then I could use a while loop like this, right? So loop over, keep looping until we come to the end, until I tell you to exit out this loop and add those names of our students into this list of names, and then at the end print out the list of names. So that's when while loops can be really, really useful when you want to create programs that have this kind of behavior. But again, with while loops in particular, you always have to make sure that you have some way to exit out of them. Either that's by incrementing our helper variables to reach our terminating condition, or including some sort of break call somewhere in our code here to make sure that we have a way to exit the loop. Otherwise, the loop will run forever. But yeah, hopefully that helped you guys get some practice with loops. I know these exercises were pretty simple, but I think it's better to have some simpler exercises for us to practice with to build a certain foundation, because I think those exercises that we covered today are pretty good to build that foundation so that you can use loops more comfortably in your exercise solutions or in your own programs in the future, knowing how to do certain exercises using either or. The goal of this was to get you comfortable using while loops and for loops and setting them up to do the exact same things. Again, one of those things I've always said as you watch my videos, as we're learning how to program, is that there's a million different ways to do the exact same thing. And in this instance, I was showing you there's two different ways for you to print out the exact same outputs, right? One way using a while loop, and another way using a for loop, and how you can go about doing that. So programming is a very open-ended endeavor. There's a million different ways for you to do the exact same thing, right? You can do the exact same thing in the same programming language by taking two different solutions. You can create the same program that does the exact same things in 4 different languages. You can use Java, you can use Python, you can use C++, you can use C# or whatever to reach the same exact functionality, right? Again, in programming, you can do so many things, so many different ways, and still reach the exact same output. This is what these exercises were meant to help you see, that I don't necessarily agree that there is one type of loop is inherently better. I mean, I shouldn't say inherently, because there are mechanisms and characteristics of for loops that do make them better. For example, not having to worry about having to exit out of the loop, right? For loops will iterate through sequences, and once that sequence is over, the loop is going to stop. So that's really a benefit to it, as well as not having to worry about helper variables or variables to help us keep track of what we're incrementing, right? That also helps. But there's certain things that while loops are a little bit better, like in this example, running an open-ended program that has to run an unknown amount of times and exit when we tell it to exit. So, and there may be moments where you have to use both in your solution. So don't be scared of either approach. Just keep practicing them. And so I will go back, if I were you, and take a look at some of the exercises that we've done from the course that that we were told to do using while loops. See if you can do those exercises using for loops, and vice versa. Somewhere where we learned how to do it, we were told to do an exercise using for loops. Go back and try and see if you can do those same exercises using while loops. You can nest while loops, as we've demonstrated in this video, just as you can nest for loops. Now, nesting for loops might be a little bit cleaner, because again, you don't have to create extra helper variables, but same functionality is achievable with either direction that you choose to go. If you have any other questions regarding loops, how to use loops, how to set them up, when to use them, any questions, just ask them in the comments below. If I can answer it in the comments, I will answer it in the comments. If it needs a dedicated video, I will make a dedicated video. Don't hesitate to ask. I try to help as much as I can to the best of my abilities and my knowledge. So yeah, hopefully you guys walked away with some good practice, with some takeaways from this video. And I'll see you guys in the next video where we'll continue on our regularly scheduled program. And by the way, I started live streaming. I live stream in the evening Eastern Standard Time, where I work on full stack development projects. So if you're curious about full stack development using TypeScript, Next.js, and all this other stuff, you can learn that stuff on the live streams. I try to stream every night. I'm not always consistent, but we did a stream last night and I think 2 nights before that. So if you want to learn a different kind of thing, then you can tune into the live streams. I try to stream almost every night. If we don't get to, I try to stream every other night, because that's usually when I have the most downtime to even film these videos that you're watching, either on the course or talking about loops, for example. So live streams are just another avenue for me to do other stuff related to programming and still be able to teach and still be able to share my knowledge. But yeah, if you enjoy that kind of stuff, the front end and the full stack web development with TypeScript, with Next.js, tune into the live streams. Otherwise, stay tuned for the regular scheduled content, which I'll continue to upload so we can get through with this course. And yeah, that's all I wanted to share. Again, if you have any questions, leave them in the comments below. Make sure you like, comment, subscribe if you enjoy the content. Thank you for all your feedback, all your support. The questions that you guys have asked so far, it gives me the encouragement to continue to making these videos and to continue to share what I know and continue to help you guys become better programmers. So yeah, let's keep pushing.